Bismillahirrahmanirrahim. Today we will talk about Lagrangian multiplier method. As we know that when we have constraint optimization, then we will use two methods. One is Lagrangian multiplier method and another is substitution method. So now we are going to discuss the Lagrangian method. In Lagrangian method, we have two things. One is objective function, one is subjective function. An objective function, it means that maximize the utility. But there are some limitation, and utility will be increased by increasing x and y, but we have some limit. The x and y should not be exceed from 12. So here we have limit. The limit portion is called subjective function, and the which is when there is no constraint, when there is no limit, it's called objective function. So now we are going to use the formula of Lagrangian. So this is the symbol for Lagrangian. We have objective function here plus we will have lambda, and then we will use subjective function. Let's say we have some objective function. Let's say the question is like this: 2x plus y, this is objective function, and 8 x and y is equal to 8. Here is limit, so this is subjective function. Those equation which have limit, it is called subjective function, and those equation which have no limit is called objective function. So now we will use the formula of Lagrangian. So Lagrangian, this is a symbol of it. So first I will write the objective function. So the objective function is this one: 2x plus y, then we have plus symbol, I use plus symbol, then I use lambda, it's lambda, and then I will use subjective function. But here we will transfer this to this side, or we will transfer this to this side, so no problem. So now I am going to transfer this to this side, so it will become like this: 8, when this is plus, when it is shift to another side, it will be minus xy. So I will write 8 minus x and y. Now we will open the bracket. It will be equal to 2x plus y plus, when we multiply lambda with 8, it will become 8 lambda, and when we are multiplying this with 8, it will be minus lambda xy. Now we are going to find partial derivatives of x, partial derivatives of y, and partial derivatives of lambda. So first I will find the partial derivatives of x. So partial derivative of x. So we will take the derivatives of those which have x. This is contain x and also contain x. So when we take the derivatives of this, it will be equal to 2, and when we take the derivatives of this, x will be removed and we have lambda and y. This is equation 1. Now we will find the partial derivatives of y. So partial Lagrangian partial y is equal to, here we have 1, y will be removed and 1 is remaining here because it contains one coefficient, and we have also y here, the y will be removed, the next portion will be remaining, minus lambda x. This is equation 2. Now we will also take the partial derivatives of lambda. So partial derivatives of lambda, this is lambda symbol, is equal to, here we have lambda, so the lambda will be removed and 8 will be remaining, and here we have also lambda, so lambda will be removed when we are taking the derivatives of this portion, so minus x and y is remaining. This is equation 3. Now from here, from this equation we will separate lambda, and also from this equation we will separate lambda. So by separating lambda, I want to zoom out. Okay. So when we are finding the lambda from these two equations, so it will be equal to like 2 minus lambda y is equal to 0. We will transfer this to this side, so 2 is equal to lambda y. So we need lambda to separate, so divide y by both sides, so this will be cancelled with each other, so lambda is equal to 2y. Now from this equation we will also find the lambda, we will separate the lambda, so here 1 minus lambda x is equal to 0, we will shift it to the another side, 1 is in its own place, is equal to lambda x. So here we need lambda only, dividing x here and dividing x here, so this will cancel with each other, so lambda is equal to 1 divided by x. So here we have lambda value, and here also we have the value of lambda, but wait, they cancel with each other, so 2 divided by y is remaining, 2 divided by y is remaining, 2 divided by y is remaining here, so the lambda value is 2 divided by y. So now we can say that lambda is equal to lambda, lambda is equal to lambda. Now put the value of lambda here, the first value of lambda, and we will put the value of second lambda. So the value of first lambda is 2 divided by y, we have equality, and 1 divided by x. Now we have cross multiplication, we will multiply here and we will multiply here. 2 multiply with 2 multiply with x, it will be 2x, is equal to, it will be multiplied with 8y. So now we will put y in this equation 3. When we put y in equation 3, we can get x. So in the next page I'm going to solve this. So I'll put in this equation, so 8 minus xy is equal to 0. I am putting the value of y, so the value of y is equal to 2x. So 8 minus x is in the formula. Instead of y, I'll put the value of y. So the value of y is 2x is equal to 0. Now we can easily find the value of x. So 8, this will multiply with this, so it will be equal to 2x square. X with x square is equal to 0. We'll shift to the another side because it is minus, so 8 is equal to 2x square. Here it is minus, when we transfer to another side it will be plus. Now we will divide by 2 on both sides, so 2 and 2, that will be cancel each other, and it will be equal to 4 is equal to x square. We just need x, not x square, so we will take under root on this side, we also take under root on this side, so it will be cancelled with each other, and when we take the under root of 4, so it will be equal to 2. Now I find the value of x, so then I can easily find the value of y. So again in equation 3 I will put the value of y. So this is equation 3, 8 minus x y is equal to 0. Instead of x I will put the value of x. So 8 minus the value of x is 2, and y is equal to 0. We shift to the another side, so 8 is in its own place is equal to 2y. We just need y, we will divide 2 on both sides, so the value y is equal to 8 divided by 4, 8 divided by 2, it is equal to 4. Now I have find the value of x and y. Now we can easily find the lambda. We can find lambda from this equation, we can also find the lambda from equation 2 and 3, from 1 and 2. So now I am going to find the value of lambda from equation 1. So 2 minus lambda y is equal to 0. I'll put the value of y here. So 2 minus lambda, the value of y is 4 is equal to 0. Now 2, it will be equal to, when we multiply lambda with 4, it will be 4 lambda is equal to 0. We will shift to another side, so 2 is its own place, so 4 lambda. Now dividing by 4 on both sides, so 4 is here, 4 is here, it will be cancel each other. Shit. Sorry. This is equation, and I put the value of lambda. So here I put the value of y. So the value of y is 4. When we are multiplying the 4 with lambda, it will be 4 lambda. So this is minus 4. I will shift to another side, and it will be equal to 2 is equal to 4 lambda. So we need lambda only. We will divide 4 on both sides, they will cancel with each other, so the value of lambda will be equal to 1 divided by 2. Now we are going to prove it, whether it is correct or not. So we can easily prove it. Here we have constraint, and they say that x multiply y is equal to 8. So the value of x and y is equal to 8. So the value of x is 2, and the value of y is 4. When we are multiplying these two, 8 is equal to 8, so it is correct. So this is the Lagrangian method.